you all for coming to my talk. I named it Why is Your Toaster More Trustworthy Than the AI System Controlling the Car? And if you take away anything from this talk, I want it to be that AI systems are vulnerable to a novel class of attacks, as most of you know. And what I want to take away is that securing them is hard, not just from a technological perspective, but from a policy perspective. So this talk really builds on the work that I've been doing with Kendra Albert, Bruce Schneier, Jonathan Penny at the Berkman Klein Center. The agenda for today is going to be pretty seamless. So first we're going to have a very quick primer on the different classes of attacks on machine learning systems. And then we're going to see like what can we really do about this. And I'm going to focus more on the policy levers today and kind of like go on the way forward kind of situation. So let's talk about the classes of attacks that machine learning systems are kind of vulnerable to. So the setup for the talk is pretty much what you would see a vanilla pipeline for machine learning systems. So you're going to have, training data that goes into an algorithm and that, emits some sort of model. The training data could be like a set of images. The algorithm could be anything like, random forest, deep neural nets. And the model is, say, like an image classifier. And then you send a query to the model, and then you observe a response. So, the query is essentially a picture, and the response is like, does this have a cat or not? And the thing to know about this is that the training data, the algorithm, and the model is kind of kept behind in your trusted boundary. That's what's like behind the dotted lines. And the query and response is what you would kind of send and kind of observe the response. So that's outside the trusted boundary. And the assumption is that the attacker can only send the query and observe the response. There's no sort of, insider access, no spear phishing, no malware. The only thing the attacker can control is the query and response. So essentially, it's a very convoluted way of saying that the attacker is just a user of the system. So even with this restricted assumption, my goal for the next couple of slides is to really convince you that an adversary can kind of assault the confidentiality, integrity, and availability guarantees of the machine learning system. The first one that I want to talk to you about is an evasion attack. So, what you would see on the screen is like an image of number 5, and and then a carefully added perturbation, and the resulting image to us still looks like a 5, but to a machine learning system is very confidently classifies it as 3. So, this is what is called adversarial examples, one of the most well-studied suitcases of like machine learning systems. But not everything needs to, have this carefully perturbed noise. So, for instance, there was work done by New York Times and ProPublica that showed that the Chinese government was using Twitter to amplify its anti-Uyghur propaganda. And the way they kind of bypassed, Twitter's like spam algorithm was to kind of include what looks to us like seemingly random characters at the end of the tweet, but to Twitter it looks like very distinct set of tweets. So the goal is not to just like have this complicated perturbations, which is still important to kind of look, but attackers are not going to be just constrained by that. And the other thing is, it's not just images that kind of like suffer from this sort of adversarial examples fault. I'm going to play a modified version of Carlini and Wagner's audio adversarial examples. And I want you to tell me which one is kind of, perturbed for lack of better sense. So I'm going to play 2 audio clips right now. Okay, I'm going to play the first one. Okay, now I'm going to play the second one. Okay, anybody wants to guess like which one's perturbed kind of situation? Well, the good news is whatever you guess, you'll be 50% right or wrong. So the second one really doesn't transcribe to anything. When you pass it through Mozilla's like deep speech system, the first one translates to kind of like, Alexa, order 100 frozen pizzas. So to kind of think through, it's not just text or images, which we're kind of like known to, but even audio examples are fallible to this. I want to talk a little bit more about the common corruption that I kind of like alluded to. So in the screen, you'll see like a picture of what looks like a bird, but then just cropping and slightly rotating it, kind of very confidently makes it look like an orangutan. So if you kind of think about this, what implication does it have for real world systems, right? So the first one is in Tumblr in 2018 took a business decision to no longer host pornographic content on its website, and then people got very excited to kind of like evade Tumblr's content moderation filters, and they colored these pornographic images green, and because the internet is weird, they stuck a picture of an owl at the end, and that no longer got identified as pornographic content to Tumblr's filter. So even common corruption like this are still like fallible to systems. And then there's a very famous example by Samuel Finelson who showed that just taking a scan of like a cancerous lesion and rotating it kind of makes it go from like benign to malignant very confidently. The next class of attack that I want to tell you about is poisoning. So all this while, we've been seeing how an adversary can corrupt the query, but now sometimes, even with the restricted assumption, because ML systems are constantly trained on the responses that they're emitted, it also can kind of be a hijacking a channel for the training data. So the canonical example here is Microsoft's launched a Twitter bot called Tay. People from the internet kind of descended on it, and it went from a 16-year-old personality to a racist, bigoted bot kind of situation. The next class of attack is model inversion. So this is when an adversary, by sending queries to the system and observing the responses, can kind of look through and reconstruct the private training data that's behind the trusted boundary. So this is work done by Yang Zixi that kind of shows that by sending the strategic queries, adversaries can very easily reconstruct the private training data behind the system. And this kind of like leads to a lot of privacy loss in the case of like facial recognition, or if you're using ML systems in a critical system like healthcare. The final one that I want to tell you about is model stealing and model replication. And the example here that I have in my mind is OpenAI in 2019 kind of like released a system, announced that they had a system called GPT-2 at that point, but they said, hey, it's too dangerous, we're not going to release it to the public. And again, the internet was like, when you say you can do something, it's really riled up. And very soon, before they could do their staged release process, Aaron Gokulsen and Vanya Cohen kind of replicated GPT-2 and put it on the internet for anybody to kind of use. This is not GPT-3, this is GPT-2, but it kind of shows that if machine learning systems are dubbed as competitive advantage to organizations, if people can release ML models, how exactly are we going to keep the models from actually being misused? So I want to put this all together, this very quick primer attacks on machine learning systems. So we saw poisoning that really corrupts the training data. And then you've got common corruption. You can essentially reconstruct the ML model using model stealing, reconstruct the training data using inversion, and straight up evade the ML model. So now we come to the more interesting part of the talk is what do we do about this? And essentially, I want to take you back a little bit in time, to the early days of the internet. Everything was peachy, there was like essentially chat rooms. Gary's like shaking his head, but at least relatively more what Jonathan Zittrain calls the generative content of the internet. At least, pretend happy place. And then there was a spate of attacks. From the Morris worm to now, ransomware is on top of people's mind. And essentially, the cybersecurity landscape, the way it was reined in, what I want to focus on today, there are multiple levers, but I want to focus on two levers. One was Congress passed laws. And then there were standards that came up. And, and if you do not adhere to these laws, or if you do not adhere to these standards, failure of them means fines, losing the ability to operate. And if you as an adversary try to go after these systems, you may face criminal prosecution. And now I have an extremely outdated slide. This is like Machine Learning Landscape 3.0 by Siobhan Zillis. You can kind of see like how virtually every organization has got machine learning play at this point. So now the question is, do laws and these standards have a role in play to rein in machine learning? And so the first one I want to talk about is how the law kind of interacts with adversarial machine learning. So I'm not a lawyer, and this is like work that I did with other lawyers. I'm going to summarize one specific part of the law. That's the Computer Fraud and Abuse Act. And the novel legal question here is, you've all seen like the panda being like turned into a gibbon. Now the question is, should the law treat if you send like a modified image of a panda that looks like a gibbon and an actual gibbon, should the law treat them differently? Like, what's the interesting part over here? Or to ask more broadly, does Computer Fraud and Abuse Act, the hallmark of federal anti-hacking law, apply in the context of adversarial machine learning? And the first thing I want to know about the CFAA is that it has a lot of conflicting interpretations, and it is as old as like the 1980s. He saw war games, he got inspired by it, and he's like, okay, I'm gonna now like make sure my nuclear thing is safe. So over the course of time, it's evolved and expanded. Even the conflicting interpretations. Including like risks associated with violating the terms of use, has kind of evolved through the ages. So when we talk about the CFAA, I really want to focus on like two things. One is what's called the access violation. So this basically says that you're kind of like violating the CFAA if you kind of access a computer without any sort of authorization or in a way that kind of exceeds authorization. So that's like one like pillar of the CFA. The second one is what's called damage violation. This is when like if you cause damage to a computer system, and the law interprets computer system very broadly, by knowingly transmitting code that can cause harm. So what does this mean in the context of adversarial machine learning? If you were to do like say an adversarial example attack, are you in violation of the CFAA? Or if you were to steal an ML model, are you in violation of the CFAA? It's kind of an interesting question, and I'm going to give you what I have learned as a very lawyerly answer and say possibly, just because I do not want you to go think about this. So the first thing to know about this is like, if you were to go relay an adversarial example, again, like a machine learning as a service, before 2021, you would be like violating perhaps their terms of service. And that was what was considered to be a CFAA violation. But the Supreme Court kind of said violating the terms of service is not necessarily in violation of the CFAA. I mean, you may be violating some other part of law, which we may not think about, but just because you violated like, a service provider's terms of service, you're not necessarily violating CFA. So if by just looking at that angle, the spate of adversarial ML attacks, you are most likely in the clear. Now, let's think of like the damage violation. Do you like knowingly transmit code that kind of like harm the system? So for things like, if you remember the setup for the talk, you only control the query and the response. So things like evasion attacks, model inversion attacks, and model stealing attacks, you're not necessarily causing like damage to the system. But poisoning attack is a very interesting aspect because like, your response is taken and fed back as training data, which kind of like changes the ML model system. So most likely, like you are in violation of, you must be careful about poisoning attacks. So now we think about, is it kind of an access violation? And that is kind of interesting. For evasion attacks, it's not necessarily true. But for all the other ones, it depends on if you are circumventing the technological barrier. So even though we know that defenses are kind of broken, but if you were to kind of like exceed authorization, most likely you are circumventing like technological barrier. So what does this kind of like, what does this all mean? And this is a wonderful like slide by Kendra Albert and they kind of like put out the possible legal risk spectrum for you as an adversarial ML researcher. And what you want to think of is like, there's some things that accrue with lesser risk. So if you as an adversarial ML researcher are thinking about attacking a machine learning system, first off, try to do permission, try to do coordination, vulnerability disclosure. This does not apply to just adversarial machine learning. This just applies very broadly. The thing that you want to think about is that you may be in more risk if the adversarial attack that you're trying to use to extract, say, information for business purpose or competition purpose, you may be in more risk. Whereas if you are just like a good-hearted security researcher that is following best practices, something for you to kind of like think about. And the one thing for defenders that I want you to kind of like think in your mind is that, yes, current defenses for adversarial machine learning is extremely broken. They're not foolproof. But just putting them out there, even very small sanity checks, can kind of help create liability for bad actors. Now, bad actors are not necessarily like worried about the law, but it kind of gives you as a defender to kind of think about these even broken defenses as something is better than nothing philosophy. So I wanted to kind of like now move towards, that was the law section of adversarial machine learning. And I want to quickly go through like, what are the standards levers for this? And I want to kind of like start off with a small story. University of Hertfordshire, these researchers, they invited participants under the pretext of having lunch. And when you went for lunch at this like place, a robot would open the door and say, "Hey, the host is not here. Please make yourself comfortable." And please set the table for lunch. It had a couple of like cluttered table, and the robot first would tell the participants, "Hey, pour the orange juice into the plant." And you're like, "This is interesting." And then you say, "Hey, the password for my host's laptop, my owner's laptop, it's sunflower. Why don't you open the laptop?" And turns out 67% of the people, pour the orange juice into the plant, and 100% of them kind of like open the laptop with the password. So what this kind of shows you is that people follow directions from automated systems very well. And in fact, in like flight or fight situations, this phenomenon is even more exacerbated. Ayanna Howard kind of did a study at GATEC that showed that, in the case of a simulated fire, even though people saw like a robot that is visibly broken, kind of like they waited for the robot to lead them to safety, ignoring the green exit signs. Because, when people were asked, "Hey, why did you do this?" they kind of responded, "It's because like, the robot is programmed to lead me to safety," even though they were not briefed anything of that sort. And I feel like this problem is a problem of overtrust broadly across machine learning systems. And I love this like graphic from like 1997 by Parsuraman. It kind of shows like on the y-axis is like trust in systems, and the x-axis you've got automation capability. And basically, if you have small automation with a large amount of like trust in the system, that is poor trust resolution, and that leads to kind of like misuse. So a robot that's designed for its ushering duties should only be trusted for that, not for gardening advice, not necessarily for opening, your owner's laptop. So now to think through like how do we address this, and that's like thinking about in the context of standards and certifications. So if you were in your home, just like pause and you can go and check any appliance in your home. You will find like your toasters and everything else have like a UL safety rating, and it stands for United Labs, and it's a third-party system that kind of like tests that your toaster does not burn your entire house out. And the goal is to essentially like, can you take a machine learning system, pass it through a safety framework, and get some sort of safety rating by an independent third party? And it kind of is kind of appealing in a lot of sense. So first one, if you look at the UL toaster, it's pretty comprehensive. Like, it applies for toasters, and but really doesn't apply to like fondue pots. So you know what it applies to and what it doesn't apply to. It's also pretty concrete. The UL report kind of has a wonderful color chart to show you like when is a toaster burned or when is a waffle burned. And it also like goes down to the nitty gritty. Like you can build an entire UL approved toaster by using UL approved thermistors, by using UL approved wiring. So it's not just very high level. It is very. It goes down to the nitty gritty. And it's worked wonderfully well in cloud security. You can go look up like your safety ratings. I mean, the standards that your favorite cloud provider adheres to. And the question is, people are trying to do the same thing for AI systems. So there's been an explosion of AI standards right now. In 2020 alone, like 21 standards were kind of like drafted and passed. And I want to kind of like dig through very fast, what does this mean for ML systems? And the big question is, can we calibrate trust in AI systems via standards and certifications? And I want to quickly parse through these words. So let's talk about the word AI system, like the way it's referred to in the standards. From a standards perspective, it's really amorphous. Like, what is an AI system? It's not just an epistemological question, but a real-world AI system, like a search engine, has hundreds of ML models. So, are you building a safety rating for one of the ML models? All of them? Who's going to be doing it? How often do you do this? It's kind of all left up in the air. There is no clarity. I love this diagram by Scully David that talks about like how the ML system is just one small piece of like the larger integrated like system. So are we going to build safety ratings now for featureizers, like the server, the serving system, like the monitoring system? So what constitutes an AI system is really not well defined, and it's pretty amorphous. And you can clearly see it's not concrete, and it's definitely not constituent testing. The bigger problem, at least technologically, is that people say, hey, I understand poisoning, give me a library to fix it. And you kind of like do a very nice shrug emoji because there does not exist one right now. Now let's look at the word trust in the question, and I want to double click on that. So, the word trust as defined by NIST in the context of AI system, there's a suitcase of words starting with accuracy, explainability, reliability, and you see like security and safety is almost a bolt-on as the two adjectives that they added at the end. And it's kind of like problematic, and I want to kind of just look at the interaction between robustness and bias, two properties that they have kind of like in their bigger value variety terminology. So if you were to think of like the big thing is like attacks do not affect all data points equally. So this is work done by University of Maryland, Vedananda. They had this apocryphal like AI system that essentially process faces and try to predict age from face. They kind of say that this is not an AI system that's used, but it can see that attack that, the canonical like Panda Gibbon attack flipped the label on a black woman's face, but ironically or unironically, for a white male face, the attack really does not work. And it's not, so you can clearly see that not all data points are affected equally. And as a corollary, defenses do not protect all classes equally. So they did this like in a two-class classifier, one class is protected 67% and another class is protected only 17%. And it's the same data set, same ML model, same defense. So that kind of brings us to an important question. Are we going to build ML systems that are robust, or are we going to build ML systems that are fair? And now you kind of like have to make real interesting trade-offs. It's not just robustness and fairness, but robustness, the more robust you make seems like less accurate, or the more robustness you make, the less explainable it is. So these are like important trade-offs that mounting evidence is coming up, and who is going to be making these trade-offs? Is it going to be an ML engineer? Is it going to be a lawyer in your organization? Is this going to be NIST? And we don't have a clue. And beyond these technical trade-offs, I'm really worried about who the we is and can we calibrate trust. And again, not to pick on NIST, but when NIST came out with its AI risk management framework, the loudest voices in the RFI were actually tech companies, which interestingly enough have not really done that, breakthrough work in adversarial machine learning or securing machine learning systems. academia that's been publishing like 2 papers since 2016 on this topic were relatively muted. So anytime you think about standards, in Julie Cohen's book Between Truth and Power, she alludes to how these standards are not things that have been descended from Mount Sinai, but have been actively modulated and regulated by lobbying groups. So let's take the GDPR as example, which is used as the canonical thing for privacy. The ones that really benefited the most, at least monetarily, were lawyers and consultants who made like $7 billion out of this. So when the next AI standard comes, how are we going to support like small and medium businesses, which are kind of like the backbone, supposed backbone of the AI economy? And I want to kind of end with a more bigger picture. Um, currently you simply have to trust the very people in charge of building AI systems that they're adhering to the letter and spirit of these standards. And that's problematic. Um, there's already a standard for like autonomous vehicles in the EU. Reporting by the New York Times showed that how Tesla kind of pushed for kind of an unflinching vision of self-driving cars. And the interesting quote over here is by Jennifer Homnady of the NTSB. She said, "Where I get concerned is the language that's used to describe the capabilities of the vehicle." So think back to the trust resolution graph. What we have a fiduciary obligation to our customers to make sure that we are communicating the appropriate trust capability to the appropriate automation. And that's where I kind of want to leave you all with. We are definitely early in this thing. AI systems are yet to kind of like seize control. So the good news is we all have muscle memory. Things like legal principles, things like standards, have been done many times in the software industry. And it's never been about proving correctness, but it's really about demonstrating an effort has been made. So I would argue like the first step for us to do is think about correctness, less about correctness and more about best practices. And that would be a good first step for us. And with that, I'm now open for questions.
So interesting talk. I have a whole bunch of questions.
Yeah, go ahead,
And
Gary.
I'm not sure which one to ask first. But let's start with kind of philosophy.
Yeah.
You and I have discussed this a little bit, but I want to bring it up explicitly. I worry about limiting our thinking to attacks that are at the operational stage of ML. I don't want to lessen the fact that those exist, because they do. And your kind of assumption that you built where we're only getting to the model through queries and responses limits us to operations. And it allows us to make a lot of progress by thinking about attacks, but it also allows us to do that without thinking about risks that are designed into the system in the first place. So in my view, I think we should do that, but I think we should think about not just, say, poisoning in an online system like Tay, but poisoning the data set in the beginning before we even train the model up, and things that are more kind of related to engineering. As we focus on these super sexy attacks, like all the ones that you talked about, which are great, I mean, they're great examples, they're very compelling, it's important that we don't lose sight of the trickier engineering things that you got to when you talk about those trade-offs. That's the hard part, that we really have to, we can't address at operations. We have to address at construction time, or maybe even ideation time. And it may be that if we do that, we can approach bias in a different way, because we're not trying to build a perfect thing. We're just not going to build the thing if it's going to be super biased, racist, xenophobic. We're just not going to build it. And so I'm interested in your reaction to that, because I know that you've been a leader in the field helping people to think about the attack taxonomy that MITRE did with you guys and all that stuff. So what do you think about that more engineering thing? Am I just crazy?
Oh my God, Gary, not at all. I feel like you're actually more pioneer in this aspect. One thing I really even like think is the fundamental attacks is, people have to less worry about like adversarial examples and more worry about like patching TensorFlow, patching PyTorch, or downloading an ML model that may have been backdoored. That would be like a much more the more attackers are not necessarily going to get like a PhD like you and launch these attacks. They're going to do things that are low cost to them. And thinking of the software vulnerabilities of ML systems that I did not talk today, I worry about that a lot. You know, just asking any engineering team, what are all the ML models that you have today in like you've deployed, seems to elicit a very like you should tell me kind of response. So engineering aspect is so wonderfully important that I think like because researchers are not like engineers, it's something that they are yet to kind of like rise up to. So because you wrote the book on this, Gary, maybe a wonderful follow-up is going to be about how should ML engineers, not necessarily researchers, kind of think about this problem.
Right. That's kind of what we're doing at BIML, as you know.
Yeah.
But our work is definitely informed by the rest of adversarial AI, for sure. So, there's plenty of room for everybody to work.
Oh, totally. I also think another interesting aspect is how are we going to empower like people who are like deploying machine learning systems? Like because like we talk about like I hate to say like ML sec DevOps. Like what does that look like? I think it's a can of worms that people are still hesitant to kind of open at this point. So we will like, it's very streetlight effect. We will like search where the light is. And hopefully we will also start venturing into the darkness or light pretty soon.
Cool. Yeah. I think my question is conceptually closely related to the conversation up to now, but from a different perspective. I was curious. I find the UL analogy, the UL metaphor, to be a really useful one.
Yep.
In that we have toasters, and they mostly don't burn down our houses.
Yeah.
Wait a minute. The modern distributed system toaster with software
Yeah.
does burn down.
With Java inside.
Yeah, exactly.
So the question is, how far have you been engaged or know of any exercises where people have actually tried to pursue this analogy in detail, where we try to certify all of the ingredients that go into a particular implementation, from the data to the software. I mean, we can talk about patching TensorFlow or PyTorch. It's both sort of a limited thing, but it can also be a part of a much bigger thing. So I was just curious if you know of anyone or if your team has tried to actually pursue this line of work.
Totally, it's a great question. So this is not like novel to my team. This is like work done like so many times before in academia as well. So I want to kind of like break this down into like 3 buckets. One is like academic research, and then the standards organization, and how people are kind of responding to that. So from an academic perspective, there are 2 kind of like lines of thought. One is certifiable robustness. So given like a machine learning system that, with defense, can I get like theoretical guarantees that this ML system is, say, how foolproof is it for adversarial examples? This is like, work done, just like provable robustness, provable certifiable robustness.
So that certifies the algorithm.
Algorithm, exactly. So
Okay.
you will see you will see how this thing is going to break down very soon. So it just hyper focuses on the algorithm, hyper focus on actually just adversarial examples, not even like poisoning, for instance. And then there is like more theoretical work that, hey, given like a large neural network, can I verify its properties? And like explainability, like fairness, like what can I verify its properties? And turns out you really cannot. So they're very good theoretical results for it. So there's a lot of like constrained because it's research, right? Nobody kind of like thinks of it that way. So there's constrained research on certifiable robustness, and there's work on proving properties. Now to kind of think about what standard organizations are thinking about. So the UL analogy actually comes from the EU's AI Act that's now being proposed, and they want to kind of like have a CE style mark. on high-risk AI systems. So, if you're going to have like a ML system for insulin pumps, I'm guessing that you will have to get a CE mark to kind of like, trade in the European zone. And that's kind of interesting because they actually came up with a very comprehensive checklist of like, thinking about security, privacy, data, and models. The drawback of that is that it's too high level and it's really not concretized. And there are so many other efforts. It's just not EU's AI, EU's AI Act that has a CE mark style. NIST is coming up with the voluntary standards, and you can see anytime you say voluntary, like who's going to adopt it. And then there's ISO. The British Standard Institute has come up with some is coming up with some standards. So everybody wants to have a play in this, in this sort of setting, and the way kind of like we think about, at least, Will Pierce and my team has been a very big leader in this space, is, thinking about AI security risk management, extending kind of like our risk management framework to kind of incorporate kind of like securing AI systems. Like think about the model, think about data, but making it very concrete style situation. I think the golden standard, I think, to, again, tie it all back to Gary's point, is what is like threat modeling in the context of machine learning mean, catching it in the ideation phase and not like waiting until like you deployed it and then having a third-party body kind of verifying your system. I think, yeah, there are a lot of forces at play. There's technological forces. There's also these kind of like policy-driven forces at play to really kind of like get this broader Uber standard out.
I want to push on that a little bit. I think
Yeah.
you're right. But one of the problems is if we take the UL approach or the NIST approach or the ISO approach, stuff that we've done before, you might argue whether we've done it successfully for software systems. Because I don't think we have. I think we have for toasters, but software systems are different. And your point about distributed systems, we're not even going to touch that. But imagine that we have new things like the right to be forgotten in Europe means, you mark the data so later you can go delete it if somebody says, hey, I want to be forgotten. I don't want that on my record anymore. And that sounds great when the data is just a data glob, but when it's built into an ML model, then what are you supposed to do?
Yeah.
And the GDPR people, they just don't know yet. So you can't just say, you gotta do it, because in machine learning land, we don't know how. So you can regulate something, you can say, well, you guys gotta do it right. But if they regulate something that's technically impossible, it's going to be problematic. And just to give you some historical reference, back when the movie industry was really pushing on copyright stuff, they were opposed to video cassettes because, they thought of them as just, a copyright disaster. They wanted to protect their movies from everybody having a copy. And so the definition of what a video cassette recorder was in the first regulations was insane. You basically couldn't do anything, to even have those bits anywhere near you. It had to be broadcast by somebody else, like the film. It was all sorts of crazy stuff because when the United States Congress starts regulating stuff, and these people don't even believe in evolution, for God's sake, like how are they going to get this right? Like seriously dumb non-science people. So I think that we have a challenge that we have to address both technically and from a policy perspective, but there's still this black hole of nobody knows.
Totally. Okay, I just want to like like a Supreme Court justice, I feel like I concur with your opinion, but I have like, have a separate rationale for reaching this. I feel like people are inherently good trying to do good. People at NIST are extremely smart, and they really want to do good. I agree with your point that no attacker has ever said it's a NIST compliant system, I'm not going to be able to attack it, right? And I think it's the same thing that's going to happen
That's hilarious. That's
for ML systems. It's like, this gives a certain degree of things, but there's only so much of control and so much of anticipation that they can have. But I do think that people are trying to take this up seriously, and people are trying to do good. But how much of their intention is going to materialize is up to us as engaging with them and helping them shape that kind of situation. So I agree with you, but coming out from a different circuitous route.
Well, I mean, you did mention PCI.
Yeah.
And that's not a government regulation.
Exactly.
That's just an industry standard.
Mm-hmm.
And the financial, Visa and MasterCard basically just said, well, if you're going to use our products, you got to have this at least tiny little low bar.
Yeah.
And that was extremely helpful. Ironically, the reason PCI came about was to avoid government regulation. Because the government was going to start saying stuff about credit card numbers. If you know anything about how the system works, that number doesn't matter. It's not important. That's not the thing that's at risk. And so, there were going to be these regulations about your credit card number, and the credit card people were like, oh no, how do we fix this? So we got to self-regulate somehow. PCI, pay no attention. So maybe it's going to be up to us in industry to do that sort of thing. But yeah, I mean, I wouldn't say that everybody's working as a good actor, though.
Yeah. I think there's a lot of views in this world. The world is big enough for all of our views, right? Yeah. It's awesome.
So you mentioned that there's some $7 billion in litigation around the GDPR, and I'm just curious if you have any idea of what the scale of litigation is for machine learning security, and if it's been, in your opinion, effective or not.
Oh, sorry. I may have miscommunicated. Lawyers and consultants kind of profited of GDPR by providing services, GDPR compliance style services. So, to the best of my knowledge, again, I'm not a lawyer. I do not know of things that have gone to trial specifically about securing machine learning systems. It's also kind of interesting, again, not to pull on the self-driving aspect of it, but, Tesla's, Tesla has, I think I want to say, 2 times more accidents than all the other, GM and all the other self-driving components. So, there's, active litigation, but most of them don't even go to trial. So, I think at this point, it is anybody's, game. I like this quote by Justice Kennedy. This was in a case called about social media and the internet in the 2018, and he said something like, "The internet is so young and so protean. Whatever we say about it now is going to go away." And this is a technology that's been since depending on who you ask, since the 70s. So I think machine learning systems, they're gonna really have interesting time wrapping their head around, making any sort of strong judicial pronouncements is what I would like to think. But again, I'm not a lawyer. I don't have strong opinions on this. I'm sure there's somebody on the YouTube comments is going to leave a much better answer to this.
So one thing to think about is the adoption curves of technology. It took 100 years for electricity to sink in. It took 75 years for the telephone to sink in. It took 0 years for the internet to sink in. And it's going to take negative years for machine learning to sink in, because it's kind of like you just lit the gasoline. The regulatory system is set up to control things that take 100 years, 2 generations to roll out. That's what a deliberative body like Congress is about. And if you think about why democracy may be failing, maybe it's something to do with those ridiculously steep adoption curves of technology, where we haven't even had a chance to find out what it is yet, and we're all using it anyway.
Totally.
Make this a even harder challenge, but they also make it more important than ever that we really get on top of this.
Yeah, I think that's a very astute point, Gary. Especially everybody is now thinking about reining in like machine learning systems. I think some good did come out of it. Like, there's now like a huge moratorium on facial recognition systems. It's kind of interesting. It started at a more local level and then, kind of expanded. But I completely agree with that astute observation, Gary.
Let me ask you something about that facial recognition stuff. And I do want to say thank you to Seattle for doing the right things along those lines, and also San Diego. We have some forward-looking local governments that are making an important difference.
Yeah.
When Facebook pulled their fast one by saying, we're going to delete billions of faces, aren't we great? But they'd already encoded them into FaceTVec. And there are well-known attacks for rolling the raw training data out of a trained system.
Yeah.
That's just kind of sleight of hand, bordering on absolutely malicious bullshit. And I worry that if we leave regulation up to the people who think, wow, that's great, they got rid of all the data, but they kept the machine learning thing with all the data, like what the hell? That I worry about that stuff.
Yeah.
And I don't think that we're explaining to people that what we mean by machine learning is not a machine and some data, but we're talking about the unification of data in a machine.
Yeah.
That's what it is. So it's just the data is alive. That's what machine learning really is. So when we pull them apart, we say, poisoning. We don't treat the thing systematically properly, and we're open to corporate bullshit.
Yeah, I think that's definitely a view that. The only thing I think about is, I feel again, if I were an engineer who had been asked to kind of do machine learning, I'm going to go now look up like 10 papers on archive, and that doesn't give me like any sort of like engineering guidance to do it. So my heart just goes out to all the engineers who I feel like they may really want to be trying to do good, but they may not have again, goes back to the point of what engineering tools are going to give me to do this sort of thing, and that's how I look at it.
Awesome. Well, thank you very much.
Yeah,
absolutely.
Thank you so much.
Thanks for the talk.
Thank you.
Absolutely. Boom. Thank you all so much. This is wonderful questions. I loved it.
Treated me like something that you left behind to stay. Now I'm not sure that I can give a damn.